Next question. A 1.2 meter tall girl spots a balloon, a hot air balloon basically, moving with the wind in a horizontal line at a height of 88.2 meter from the ground. Okay, let us make the diagram. Let us first make the ground first. Let's assume that this is the ground, and the girl is 1.2 meter tall, and the girl observes a hot air balloon which is moving horizontally, but it is constantly at 88.2 meter from the ground. From the ground, that is very important. From the ground, the hot air balloon is 88.2 meter. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degree. So the first position, basically, actually I have just made it, this is the final position. The first position of the balloon is, hot air balloon is this one, and then it makes 60-degree elevation on girl's eyes, and then the balloon just moves horizontally some distance which we don't know, and after some time the angle of elevation reduces to 30 degree, and they are talking about this angle of elevation. When the balloon has moved here from point A to point B. Find the distance traveled by the balloon during the interval. Find the distance traveled by the balloon. It means we need to find out what is AB, because this is the distance traveled by balloon. Okay, so basically let us go forward solving this problem. So again, I think it's very similar to what we solved earlier, but let us just have a look. So I have just drawn a line. I think, no, this is not, it could be F. So the girl's eyes are on point F, and then I have just put one horizontal line EF, which is horizontal to the ground, CD. Ground is CD, isn't it? I can also write down here if you want. This is ground level. And the girl is standing at the same position. What will be BE? BE will be BD minus ED. BD is height of the balloon from ground minus ED is height of girl. and that is the height of observation, because her eyes are at 1.2 meter. So 87 meter will be equal to BE. So this is 87 meter, isn't it? So we need to find out what is AB. So it's a very different kind of problem, isn't it? So first of all, we need to think how we can solve it. So let this distance AB be anything. Let it be H, or maybe just S. This distance AB is assumed to be S, which we need to find out. And then uh, let us do some construction, because there is no clear cut um, equations involving AB. We want to involve AB or the distance S. So basically we cannot take these triangles perhaps into account. It may not give us any useful results for our solution. So what we will do, we will just do some construction. I will do it in some different color so that you can see. Let us continue this line or extend this line up to this point, and let this be CDF point G. And then we know that this will be 90 degree, this will be 60 degree, and this will be 30 degree. Is there any issues in comprehending this or understanding this? Now we are actually thinking upside down. Why? Because I think there is nothing which we can gain by applying something here. Yeah, perhaps we can gain something. Basically, we need this distance, because this will be equal to this, or you can say GE, FE, FE is equal to GB. So why not to find that one? So in triangle, DFB, tan 30 degree will be equal to perpendicular divided by base, and base you can just call it FE. So with this we know that tan 30 is 1 divided by root 3, 87 by FE, and with this one we can actually find this distance. 87 root 3 meter. So this will also be 87 root 3 meter, because these two things are these two up to this point basically. because these two distances are same, isn't it? um Now we can apply our trigonometrical ratios in the triangle, in this small triangle, yellow triangle. Let me name this point as H. So now in triangle GHF, do you know how much is GF? GF is equal to BE is equal to 87 meter. And what is GH? No, we don't know GH. GH we don't know, but we know the angle here. This is 60-degree angle. So we can apply this trigonometrical ratio. Tan 60 will be equal to this divided by this, because this will be the perpendicular and this will be the base. So in a way, P by B, isn't it? So 87 divided by GH. So what does it give us? GH will be equal to 87 divided by tan 60 degree. So 87 divided by √3 meter. So now we know GH. But the basic thing which we were required to find was BH, or how much the um, balloon has traveled, isn't it? So here you can see that we have actually found BG, and we have also found GH. So minusing these two, we can find this distance S, which is from this point to this point, from point H to point B. So the distance which we are interested in is basically this one, and that is what we have defined as distance S, or BH. So you can just rearrange it in some good manner, also derive it with decimal numbers. It all depends upon you, but this is the solution. So the balloon, hot air balloon, will travel around this much meters, and that is from here to here. So that is the solution of this question. Can we take just one last example for the height and distance? Next question. As observed from the top of a 75-meter high lighthouse from the sea level. Okay, so we are actually observing from 75-meter high lighthouse. This is lighthouse, let it be AB, and we are observing from here, this point, from the sea level. Yeah, the angles of depression of two ships are 30 and 45 degree. Okay, so we are observing one ship here and another ship maybe here, and this is the sea level. Ship number one here, ship number two here. So just name it, and this is 45 degree. And why we have directly written it 45 degree? Because this is actually 45 degree angle of depression, so this will also be equal to 45 degree. And similarly, this is 30 degree, so this will also be 30 degree. If one ship is exactly behind the other on the same side of the lighthouse. Okay, so here we are not telling that, okay, one ship is this side of the lighthouse and another ship is on this side of the lighthouse. No, we are not telling anything like that. Both of the ships are on the same side and on the same line basically. It's not that one ship is here. So these assumption makes things little more clear. Now, what is required to be found is the distance between these two ships. So the distance here, you can very well see that the distance between these two ships will be the distance CD. So CD is what is required. So let it be S distance, which we need to know. Let it be distance S between point C and point D, which are two ships. Okay, let us just if you want to solve this problem by yourself, stop this video, try it. Now I will again proceed ahead with our thinking. Okay, so here also we can see that we have basically two triangles. One is this one, and then another is this triangle. So let us first take triangle ABC. So here we can very well see that tan 45 degree is equal to perpendicular divided by base, and that is 75 divided by something which we don't know, BC. But then tan 45 is equal to 1. So 1 is equal to 75 by BC, and that gives us the value of BC. BC is actually 75 meter. So AB is also 75 meter. BC is also 75 meter. Now let us consider the bigger triangle, that is triangle ABD. Here also we can try to apply trigonometrical ratio of tan 30 degree. Here also will be equal to AB divided by BD, isn't it? And AB is again 75 meter, the height of the lighthouse, divided by BD. So BD is basically 75 plus CD, which we have actually defined as S, distance S. Either you can write S or CD, it doesn't matter. So here tan 30 degree is equal to 1 divided by root 3, and then 75 divided by 75 plus CD. Now it's just a matter of solving this equation. We will just reverse both of the sides, LHS and RHS. Root 3 is equal to 75 plus CD divided by 75, or root 3 is equal to 1 plus CD divided by 75, or root 3 minus 1 is equal to CD divided by 75, and that gives us the value of CD, which is equal to 75 and then multiplied by root 3 minus 1 meter. So that is CD. So this is the distance between two ships. So the distance between those two ships will be 75 multiplied by root 3 minus 1. That will be our answer.